Hi girls, in this video I will take you through the formative assessment task 2. As always, if you need help with the steps, watch the video. If you just want to check your work, there's a Word document with the answers on the Ultranet. You can just go there and check that you've got all the units and the steps and the values correct. Alright, let's read this question and see what we need to solve here. Mackenzie collected the following results from her titration of sodium hydroxide against sulfuric acid using phenolphthalein indicator. So in the burette you had 0.150 mole per liter of sodium hydroxide. Now I've told you that as soon as you see mole per liter, you know that the unit is now, the value is for the concentration. So I've been given the concentration of sodium hydroxide. Then they say in the pipette there was 20 milliliters of sulfuric acid of unknown concentration. We don't know its concentration, but we do know its volume. That's milliliters there. As always, I say as soon as you start your assessment, draw a little calculation triangle so that you can use that for the steps that are to follow. So right on top here I've got n, lowercase c, and uppercase V for volume. Alright. The other thing I also recommend you do is when you have these the two chemicals you're dealing with is sodium hydroxide and sulfuric acid. So draw a little column that says known chemical and the unknown. So with the one that gets to be labeled as known is the one whose concentration we are given. So since I know the concentration of sodium hydroxide, your teacher will write this up on the board during the assessment. That becomes the known chemical. So I've put sodium hydroxide under known and hydrochloric acid, it's sulfuric acid H2SO4 under the unknown. Alright, so I know the concentration of sodium hydroxide, it's 0.150 mole per liter. I don't know its volume right now, but I can find it out from the table here. And using these two, I can calculate N, which is the number of moles, because this little triangle, the calculation triangle says that N is equal to C multiplied by V. So I can calculate the number of moles. So that will give me the number of moles of sodium hydroxide. I use that to calculate the number of moles of sulfuric acid, which we need to go back to the balanced equation for. We are already given the volume of sulfuric acid. We know the sulfuric acid is 20 milliliters. So 20 milliliters, I convert that to liters, that is 0.020 liters. And I don't know the concentration, I need to calculate the concentration. That's the whole idea of the experiment. Okay, so when you put this table, when you have these two columns, what it does is it just helps you go through the steps. So the first step will be to calculate the number of moles of sodium hydroxide. The second step will be to calculate the number of moles of sulfuric acid. And the last step will be to calculate the concentration of sulfuric acid. Alright, now I'll come back to the balanced equation in a bit, but for now I want to focus on getting the volume of sodium hydroxide. So look at the table that I've been provided with, and I want to tick the concordant results, those which are within 0.2 milliliters, and put a cross on the results that I'm not going to use. I also do not use rough, so the rough gets a cross straight away, not going to use this. Now of the remaining 4 titer volumes, I'm going to choose 3 volumes. You're only allowed to choose 3, and they must be 0.2 milliliters with a difference of 0.2 milliliters of each other. So the difference here is 0.2, the difference here is 0.1, and the difference here is 0.25. So the 3 volumes I'm going to take is, I'm going to take this one and this one. These two, the difference is 0.2. I'm going to leave this one out and take this because the difference here is just 0.05 and the difference here is 0.15. So it falls within my 0.2 milliliter range. So those are the 3 volumes that I've chosen. The next thing I need to do is calculate the volume of sodium hydroxide. So I need to find the average volume. So what I'm going to do is take these 3, 23.30 plus 23.50 plus 23.35, and that's all in milliliters, and I divide this by 3 because I want to find the average. Okay, so our calculator here, key these 3 numbers in. 23.30 plus 23.50 plus 23.35 is equal to, divide that by 3, and the answer I have here is 23.38333333. So there's actually 6 3's there. 1, 2, 3, 4, 5, 6.38. Okay. Now the other thing I know is that this volume is in milliliters. However, all of our calculation is done in liters. It's always mole per liter. So I need to convert this to liters. To do that, I divide by 1000. If I divide this by 1000, then I can convert it to liters. Alright? So when I divide by 1000, this volume will become 0.02338333333 liters. So I'm copying all of the numbers from the calculator without leaving any of them out. So I just make sure I do this on my calculator as well. Divided by 1000, and I've got 0.02338 followed by 6 3's, and the unit is liters. So I've got the average volume of sodium hydroxide. The next thing I need to do is now find the concentration of sulfuric acid. So we need to go through those 3 steps. Step 1 is to find the number of moles of sodium hydroxide. Now I know 2 quantities of, in this triangle for sodium hydroxide, I know the concentration because that was given to me by the teacher, and I know the volume because we got that from the table. So we can multiply these 2 and we can calculate N. Okay, so that's what I'm going to do in step 1. So that's going to be concentration multiplied by volume, which is equal to, what's the concentration? It's the value given by the teacher, 0.150 mole per liter, multiplied by volume, which is this number here, 0. When you're copying it, make sure you've got the right numbers here, 338 6 3's, and that is in liters. So the per liter and the liter will cancel out, and my answer will be in mole, which it should be for N. N, the unit is mole. Alright, so I bring my calculator back. I've got the numbers sitting here. I don't clear anything, so it makes it easier for me. All I need to do is now multiply it by 0.150. And my answer here is, which is equal to, so that's 3.5075. The E here is exponent, so that means it is into 10 raised to the power of -3, and the unit is mole. Alright, so what have I just calculated? I've calculated the number of moles of sodium hydroxide. It is 3.5075 into 10 raised to the power of -3 mole. So that takes me to step 2. What I'm going to do in step 2 is find the number of moles of H2SO4, which is the other chemical. And for this I need to go back to the balanced equation. Okay, so let's go to the balanced equation. Now read this. 1 mole of sulfuric acid reacts with 2 moles of sodium hydroxide to give us 1 mole of sodium sulfate 2 moles of water. These two chemicals, I'm not dealing with them here, so I leave them out. The focus is on these two. 1 mole of sulfuric acid requires 2 moles of sodium hydroxide. That means you need twice as much of sodium hydroxide to neutralize the sulfuric acid. The other way to look at it is you need half the amount of the sodium hydroxide. That will be the amount of sulfuric acid. So the relationship is, if this is 1, this is 2, it's double. If this is 2, this is 1, it's half of the base. Alright, so I come back to my problem and I look at it. Now my number of moles here is not 2 like in the balanced equation. It is 3.5075 into 10 to the power of negative 3, which is a very, very small number, much less than 2, not unlike the balanced equation. So if I have this much of sodium hydroxide, how much of sulfuric acid will I have? The ratio from the balanced equation. If you have 1 of sulfuric acid, you have 2 of sodium hydroxide. Alright, so that means if you have 2, you have half the amount of sulfuric acid. So in this case, I don't have 2 of sodium hydroxide. What I have is this 3.5075 into 10 to the power of negative 3 mole of sodium hydroxide. So how much of sulfuric acid will I have? I will have 3.5075 into 10 raised to the power of negative 3 divided by 2 mole. And this will be for sulfuric acid. Alright, so that means you have half the number of moles of sulfuric acid. So I look at the number on my calculator. That's exactly what is the numerator there, 3.5075 into 10 raised to the power of negative 3. All I need to do now is divide it by 2, which is equal to, and I copy this number down. This gives me the number of moles of sulfuric acid. Okay, so that's 1.75375 E means into 10 raised to the power of negative 3, and the unit is mole. Always double check that you've copied the numbers correctly from your calculator, because when I mark your papers, I do not see a calculator, I only see this paper. So make sure you've got the numbers right. 1.75375 into 10 raised to the power of negative 3, and the unit is mole. Alright, that brings me to my last and final step, step 3. What do we need to do? Why were we doing this whole experiment? It was to find the concentration of sulfuric acid. Now my little calculation triangle says that concentration can be calculated by dividing the number of moles by the volume. We know we've just calculated the number of moles. It was half that of sodium hydroxide. I know its volume, so I substitute these two and I can calculate C. That's exactly what we're going to do. So that's equal to N of sulfuric acid, which is the number of moles of sulfuric acid, divided by the volume of sulfuric acid. Okay, so the values here, I copy this number, which is the number of moles, 1.75375 into 10 raised to the power of negative 3 mole, and I'm going to divide that by the volume, which was given to us, 20 milliliters, which is 0.020 liters. Where did I get this number from? Right at the beginning, they told us that we pipetted out 20 milliliters of sulfuric acid. I've converted that to liters, so that's divided by 1,000, and that's 0.020 liters. So what I'm going to do is grab the calculator again. The numerator for this is already sitting on my calculator. So all I need to do is divide this by 0.020, and that's my final answer. That's the answer that we have, not yet the final answer. So that's equal to, going to my calculator, which is 0.0876875. You just make sure that you're copying all the numbers correctly. That's 0.0876875, and the unit is, you have mole on top and liter down here, so it's going to be mole per liter, which is for concentration. Now that's not my final answer because I need to give this to 3 significant figures. So I say concentration of sulfuric acid to 3 sig figs is equal to, so I start looking at the numbers from the left. Now that is not a significant number, it's to the left of a decimal. This 0 is to the right of a decimal, but it's to the left of a non-zero number, so that's not significant. This number is significant, so that's my first significant number. This number is significant, that's my second significant number. This one is significant, that's my third significant number. So I really don't need any more numbers from this answer. However, because I'm going to round off here, I look at the value that's in the 4th place. Here I have 8, which is greater than 5, so I need to round this to 7. So that will be 0.0877 mole per liter. Alright, so if this number had been less than 5, maybe 1 or 2, my answer would have been different. I would not have to round this up. It would have just been 0.0876. But since the 4th, this number here is greater than 5, I round it up. It's 0.0877. I've got the unit, mole per liter, and I've also stated what it is, which is the concentration of the sulfuric acid. Alright, I hope you found this useful, and remember there is also the Word document which has got the answer for this problem on the Ultranet.